Great, we're getting somewhere. Hi, and welcome to Python CI 101. My name is Sebastian Witowski, and in the next 30 minutes, I want to teach you the basics of continuous integration with Python. But the first 2 minutes will be about history. At the beginning of time, when people first discovered computers, life was easy. You could just write your programs exactly the way you wanted because they only lived on your computers. Of course, like most things in the prehistoric era, those programs were simple and very rudimentary, but no one cared. That was enough to keep people busy so they would stay in the cave and not be eaten by a tiger. So, the mankind could survive and the civilization slowly advanced. Things have changed with the invention of the internet. So, people started collaborating on a much larger scale, and they faced the issue of how do we make sure we speak the same language. Wars started ravaging the earth because people could not reach an agreement on how their code should be written. Events like the Great Battle of Tabs versus Spaces destroyed entire civilizations. In the end, everyone died. If only there was something they could do. This is, of course, a history from the alternative universe, but people in that universe face the same problems as we do. They were collaborating on software projects, and they needed some rules for how to integrate their code together. So this is where the continuous integration comes in. Continuous integration is a process of merging developers' code into the main repository. Each time you write a new feature, your code has to be added to the existing code and merged with the code from your colleagues. It sounds as easy as pressing a button, but there is more than that. So you need to make sure that your code works properly, so you probably need to run some tests. You need to make sure that your code is matching some common Python formatting standards, so you need to run it through Black or some other code formatter. You probably also need to run some other static analysis tools like Flake8 or PyLint that will check your code. And finally, there might be multiple people working on the same part of the code. So you need to resolve potential merge conflicts and make sure that the code still works when you merge both your changes and changes from your colleagues. A lot of those things can be automated. So let's say that each time you merge code to the master branch and you need to create release package or push a Docker image, or you need to build and publish documentation for your project. There is absolutely no point in doing all this manually if you can very easily write scripts that will automate the process of creating release packages, of pushing Docker images, or rebuilding your documentation. So the main role of a CI system is twofold. First of all, you should use it to automate as many repetitive tasks as you can. It should run tests and display you the summary of the results. It should run static analysis tools and warn you about some possible violations. And it should build and publish Docker images or documentation pages and things like that. But it's also a means to ensure consistency in your project. People use different environments. People use different development setups, different operating systems, different IDEs, and all those factors affect the code that they produce. Your colleague who's using Windows is writing a new feature that has 100% test coverage, but it doesn't matter because he used backslashes in the file paths, and the moment this code lands on a Linux server, it breaks. Or someone has a misconfigured code editor and they use tabs instead of spaces. So when you review their merge request, every line at every file they touched appears to be modified because everyone in your project is using spaces. Some people set all the formatters, linters, and other tools to fix things automatically, and some of them don't. This will make your code base full of different code styles, unused variables, and some other random violations. And you can chase those people and ask them over and over again to fix those things. But you will have to do this for every new person that joins your project. And that process usually happens during code reviews, so you will waste time writing things like add doc strings, sort imports, set the correct line length in your code editor. Or you can configure automatic tools that will fix or at least point out those things instead of you writing them down. Look, your code reviews should focus on high-level discussions about like design of some feature or maybe proposing corner case, test for a corner case of some bug that the original author didn't consider. Your code reviews should not be about code style or unused variables. All those simple things that can be detected and reported by automatic tools should be detected and reported by automatic tools. Luckily, nowadays both GitLab and GitHub comes with a continuous integration tool built in. Plus, we have a lot of commercial solutions, and of course, there are open source projects like Jenkins. So there are plenty of options. If you don't know what to choose, I suggest you start with either GitLab CI or GitHub Actions, depending on which platform you are already using. That's good enough for small projects where the cost is not too high, or actually for large projects that don't care so much about the cost of computing credits. If that option starts to be too expensive because you're paying a lot for the build minutes, then you can self-host the CI runners. So you set up a server that will run the test jobs for your CI, so that way you won't be paying for the computing credits. But at the same time, all the results of those job runs will be displayed in GitLab or GitHub, so maintaining the setup won't be too expensive. If, on the other hand, it's not about the cost, but you find that GitLab CI or GitHub Actions are missing some features, then you have to ask yourself, do I want to host and maintain my own CI tool, or do I want to pay for a commercial one? If you have time to maintain your own CI installation, then Jenkins is a de facto open source CI platform that is very extensible with all the plugins and configuration options. So it's a very good choice, and it's actually used by a lot of large organizations. On the other hand, if you don't want to spend time maintaining a Jenkins server, you just use one of the commercial solutions that has the features that you need. Okay, let's finally see some examples of CI in action. I will be using GitLab CI because, first of all, that's what I've been using in most of my recent projects, so I'm most familiar with this one. But also because, according to this Reddit survey from 2022, it's still more popular than GitHub Actions. But I'm in no way related with GitLab. They didn't pay me to come here. I know they have paid plans, but I actually never paid for GitLab myself. My clients do. So everything that I will be showing you today is available for free. And I will be using words like jobs, pipelines, and so on. So before we move on, let's make sure we are all on the same page and we understand the basic terminology of a CI. So first of all, we have pipelines that consist of different stages. So we can have a stage for building a project. I can actually use a mouse instead of pointing fingers. Hey! It's working. Yeah, so then we have stages. So we can have a build stage for building our project, then we have a test stage for running tests, and deploy stage for deploying our code to some server. And finally, each stage consists of one or more jobs, and jobs are basically a set of commands that are executed. So the run PyTest job can be as simple as just running the PyTest command, but for example, the deploy job can have multiple steps, like preparing the release, pushing the code to the server, SSHing to that server, and then restarting the web server. We also need some Python code that we can use in our CI pipeline, where we can run tests and some static analysis tools. So for that, I prepared an example repository that you can find at this URL at the top. There will be a link at the end of my talk as well. So it's a simple dice rolling program with a small twist that you can pass a --pro flag, and then you will use a 9-sided dice instead of the regular 6-sided ones. If you want, you can use it for your board game sessions with your friends, and you can allow some players to pay and get an unfair advantage over the non-paying players. This will, of course, completely ruin the gaming experience for the non-paying players, and which is exactly what is happening in all those free-to-play video games. So I think this is a really good, close to real-world example. And the code-wise, it's simple. It's just 3 Python files. We have asset.py with some ASCII for the dice. We have dice.py with the main code, and we have test dice with some tests. And here we have a small demo, so we can run it in the terminal. It will ask you how many dice you want to throw. You say 5, and we see beautiful ASCII art for 5 dice. And then we can also run it again with --pro flag. Again, we roll 5 dice. And we can see that we have a beautiful 9-sided dice somewhere there. Okay, so let's create a simple pipeline for this code. I won't be doing live demos because I don't have time to wait for the GitLab CI to finish. So instead, I'm putting different phases of our project into separate Git branches. So if you're watching this talk later and you want to see the code that I'm talking about, just pay attention to the name of the branch that I'm mentioning. So first we start by defining the base image for our CI. So here I'm using Python 3.11 Slim Bullseye. Bullseye is just the name of a Debian distribution. Slim means that this Docker image is smaller than default Debian image. So it will have less software installed than a full Debian image, but in most cases it will have all the software that we need to just run pip install and move on. And at the same time, it will be much slower than the full Debian image, so it will be much faster to download it in our jobs. As a rule of thumb, if you don't know Docker or if you don't have a specific preference for which Python version or which Linux distribution you want to use, using the latest stable Python version on a slim Debian-based distribution is usually a good place to start. So what are we going to put into our CI? Well, we have tests, so for sure I want to run my test suite and make sure that after each change I do, everything is still working. So here we have a job called test, and all it does is just runs 2 commands. We install pytest, and then we run pytest. What else? Well, we can also check the code style to make sure that the code is following the PEP 8 guidelines. We have a choice of different tools here. If we want something that works out of the box, we can use black. If we want something more configurable, we can use blue or one of the plenty code formatters that are there. I will go with black for simplicity, but later I will adjust the line length because I like to use 120 characters. And I intentionally didn't run black on my code when I first wrote it, nor I was paying attention to the white spaces and things like that. So once we add black to our pipeline, the pipeline will fail. I also want to add some kind of a linter that will tell me when I make silly mistakes, like I forget to remove some variables or like I don't sort imports and things like that. Again, 2 most popular linters are Flake8 and PyLint, although many people are moving to RAF now as well. And so here again, it's a matter of personal preference or whatever you decide with your team to use. You can of course use both linters if you want. I like to use Flake8 better because it's not so annoying as PyLint out of the box, so I'm gonna go with this one. And this is how our pipeline will look like. There are a couple of things I want to point out here. You can mark some jobs with this allow failure true setting, and this means that even if this job fails, the whole pipeline will not fail and it will continue running. And then in the end, you will see this yellow exclamation mark saying that a job that was allowed to fail actually failed. So in this case, for Flake8, I don't want my pipeline to fail if I have some linter violation. If I see the warning and I have some time to fix it right away, I will go and fix it. If I don't have time, I will fix it later. It's really not a big deal. The same rule should apply to black, but first of all, black should be running already in your code editor. So when you save a file, the file is automatically reformatted and you don't have to do anything. So it's different than fixing errors from Flake8, because when Flake8 says that you have unused variable, you actually have to go there and remove that variable. And another reason why black is not marked as allowed to fail is because I actually want to have a failing pipeline, so we have something to fix. Another interesting thing is that for black and Flake8 jobs, I am not using the default image key. I'm not using the base image, I'm defining the separate image. So this will tell the pipeline that for those jobs, I want to use the special images from the pipeline components repository. And this pipeline components is just a repository of simple, small Docker images intended to run some common static analysis tools in GitLab CI or other CI services. So here we have components for Black, Flake 8, ESLint, and many, many more. We could, of course, use those tools exactly in the same way as we did with PyTest. So we will just use the base image with Python Slim Bullseye, run pip install Black, and run pip install Flake 8, run Flake 8, and that would work. The main reason to use the pipeline components is that they will be slightly faster because those Docker images are smaller. And again, for the illustration purpose, I wanted to show you a different way how to define some common tasks in the CI. We can also select whether we want to use latest version of a given Docker image or to use a specific version. And here I'm using the latest version for Black and a specific version for Flake 8, again, only for the illustration purposes. Normally, I would always use a specific version because just like with dependency pinning in your project, this gives you much better control on which version of a given package you are actually using. So before we move on, let's fix the pipeline. If you go to the initial CI branch of my example project, you will see that both Black and Flake 8 are failing, except that Black is actually failing the whole pipeline, and Flake 8 is just giving me a warning. And we can go inside each of those jobs to see the log, and in the log we can see that Black is complaining about the formatting, and here is Flake 8 also complaining about like missing white spaces and so on. I'm gonna save you from seeing me watching how I fix the missing white spaces, and I'm gonna jump to the branch that has this fix. But one thing to keep in mind is that you can configure your static analysis tools in the CI in the same way as you configure them on your computer. So for example, let's say you finally switched from using the IBM punch cards and you want to increase the line length to something longer than 79 characters. You can do that by creating the PyProject toml or setup.cfg file with the configuration for Black, Flake 8, or whatever static analysis tools you are using. And then CI pipeline will see those configuration files and will start using them automatically. And unfortunately, we are still living in times where different Python tools can't agree on using a common configuration file format. So both Black and Flake 8 actually requires me to use a separate config file. That's why you see two examples. So by setting the maximum line length to 120 characters and running Black on my code, I managed to fix my pipeline. If we switch to the branch called fixed pipeline, we can see that pipeline is now passing with this green checkmark. Cool. So what other tools can we plug to our CI? Well, we can add type checkers like NumPy. We can add tools like Bandit that will check our code for some common security vulnerabilities. We can add tools like Vultr that will check for unused code and try to remove it. And if it turns out that maintaining all those separate tools is too much, we can plug a tool like Prospector that actually combines various different linters together. And finally, there is a whole world of the commercial tools that will give you even more feedback on your code. And of course, many of those tools can be further enhanced by adding some plugins. So a good example here can be Flake 8 that is often installed with plugins that add additional checks. Or for example, PyTest, where additional plugins can add functionality like displaying the test coverage, running tests in parallel, and many, many more features. You probably have some tools that you like to run on your computer, so chances are it's very easy to plug those tools to the CI. So let's add a plugin to PyTest that will display the test coverage for us. So here is how our test job currently looks like, and we will extend it to also include the PyTest Conf plugin and to display the test coverage. So we've added quite a lot of things here. So we defined the coverage. I lost my mouse. Yeah, here it is. I defined the coverage key with some long regular expression that defines how to find the coverage in the logs. And then I also defined an artifact that specifies that we want to keep the coverage XML file. So artifacts are a way to share files between jobs, because if you're running a job and the job finishes, all the files that were created are gone. But if you want to preserve some files, for example, the coverage report, you can create an artifact. And in case you're wondering, how did I figure out all those settings I need to write to have the test coverage, I just Googled that. If you type GitLab PyTest coverage, the first result contains the documentation page from where I just copied the code. So unless you work as DevOps and you write GitLab configuration files all the time, probably your experience will be the same as mine. You will Google different things, apply random stuff, and hope it will work. And frankly, most of the time it will work. At least for GitLab CI, the documentation is really good, so you can just copy things and work. Cool, so now when someone creates a merge request, we will see the total test coverage. And if the test coverage increases or decreases, we will also get a notification for that. So it's easy to add more tools to your CI, but with each new tool, your pipeline gets slower and slower. So you always need to find a balance between having enough tools that you can detect most of the potential issues and having your pipelines actually finish in a reasonable amount of time. Sometimes running linters on your computer is enough. For example, when you're working on your own project without a need to collaborate with anyone, but you still want to write nice, consistent code and get feedback from the linters. So in this case, you have two options. First one is to configure all those linters and checkers in your IDE, probably using some plugins. And I assume we all know how to configure our IDEs, so let's maybe focus on the second way. You can also use the pre-commit tool. Pre-commit is a tool that will install a Git hook in your local Git repository, or more specifically, it will install a pre-commit hook. That's why it's named like that. A pre-commit hook is a script that will be executed before you create a new commit. So each time you try to create a commit, Git will run this script, and if the script fails, Git will prevent you from creating a commit. And in that pre-commit tool, you can define many different checks and linters that you want to run. For example, here we can use some checks that come directly from the pre-commit tool. So we can check if there are some like leftovers from the merge conflicts, if the YAML and TOML formats are fine. We can also fix the line endings if they have incorrect encoding and remove trailing white spaces. And on top of that, we have two other tools. We are using Black and Flake 8. So exactly the same plugins that we have in our CI. The nice thing about the pre-commit is that it will try to fix whatever can be fixed automatically. So most of the time, if there are some easy to fix errors, the first time you run git commit, it will complain. So here we have Black complaining. But at the same time, it will reformat our code. So the second time we run git commit, everything will be fine and we can commit our code. Using pre-commit means that you can move some checks from the CI to your computer, which will reduce the cost of your CI, but it will also be faster. Running Black or Flake 8 in the CI takes at least a couple of seconds because you have to either build a CI container or download the Docker image. But running those pre-commit hooks in my example project takes less than a second. So it's a great tool if you can get everyone in your team to install it and use it properly. And sometimes this will be a problem. Some people might run into problems installing those tools on their computer, or maybe the version that they install is not matching what pre-commit is expecting and it doesn't work. So if you work alone or if you work in a small team, it's usually not a problem. But if you have to chase people over and over again and ask them, hey, can you fix your pre-commit setup? Just don't bother and use the CI. So with all that information, here is a setup that I would suggest to use. First, if you know how to do this, configure your IDE to run all the possible checks and formatters either in real time or when you save the file. So that should run asynchronously, and it won't block you from writing your code. And at the same time, you will see all the errors and warnings at the moment when you're making those errors. So it's very easy to fix them. If some plugins can't be used in your IDE, or just to make it easier to share the configuration with your colleagues, set up pre-commit. Pre-commit will give you feedback before you push your code to CI, so you won't be unnecessarily starting a pipeline just because when you have some easy to spot errors like badly formatted code. And finally, still use CI to have automated way to check everyone's code. That way you don't have to chase people to fix their pre-commit setup. If their code doesn't match the standard that you have established in your project, now this is their problem and they have to fix it. And in the last part of my talk, I want to give you some advice on how you can improve your CI pipelines once you get beyond this simple setup. I will just throw some ideas here without going too much into details because I have another talk about this on Saturday. So if you're completely new to GitLab CI, that talk might be too advanced, but if you're interested, I suggest you join that one as well. So speaking of best practices, run jobs in parallel so they will finish faster. Cache things between jobs. For example, you can build a Docker image in the first job and then share it between the other jobs instead of rebuilding it from scratch. Fail fast. Don't wait and waste computing credits, wasting for a job to finish if the first sign of a problem is enough. For example, if your full test suite takes half an hour to finish and already the first test fails, then what's the point of waiting for the whole test suite to finish on the CI if you already know that you have to go and fix it locally? So you can run pytest -x and this will fail the pipeline after the first failed test. Keep your merge request pipelines fast. No one wants to wait for hours before they can merge a one-line change. If you have some slow integration tests, consider moving them away from the merge request pipelines to some main branches. And also try to keep your CI setup close to your production environment. Docker is a great tool for that because you write your Docker file once and then you can reuse it in multiple places. And I hope I managed to convince at least some of you that that continuous integration can be a great tool to automate some boring and repetitive tasks and help you focus on important things. Thank you very much for listening. And I think we have some time for questions. Also, if you want, you can find me online. There's my website, there's my Twitter, although LinkedIn is a better place. And as I said, here's the repo with the code, and slides can be found on my speaker deck.
Okay. One another question is, what tools do you recommend for running CI locally?
I'm not sure if I understood this question correctly because running CI locally is a different thing. But as I said, have some plugins in your code editor to at least reformat the code or maybe give you some static analysis thing as well, and then pre-commit to not trigger the pipelines unnecessarily on some easy to fix things.
Okay, the next one. How does pytest cove work? Does it analyze the repo and reports our test coverage?
This is a good question that I don't know the answer to it, but I can speculate that it just plugs into the test that it's running and it's just profiling which lines of the code are being executed when your tests are running. Something like that.
Okay, next one. What is proper way to create CI for one project with many submodules? There should be one pipeline for main project and or many for submodules.
Oh, this is an interesting question. I think if you're like a paid client of GitLab, then you can have organization-wide pipelines, and you can also trigger pipelines from different projects. So if you have a main project with submodules, you could have main pipeline, and the submodules could have their additional pipelines inside, and then you could trigger parent pipelines from the changes that you do in the submodules.
Do you think that if CI only warn and doesn't block deployment, then is it ignored in long term?
Good question from Łukasz. It's a bit about like how you approach working. Like, of course, if you can always ignore CI. My main problem is actually the other way around. If I have some urgent fix that I need to merge and I have CI that blocks me because, I don't know, I didn't format my code properly and the production is down, then I get very, very angry at the CI. So I think if you have a person who, like team leader or lead developer or whoever, and they kind of enforce the good culture of not ignoring the CI, then you can make things optional, and that will actually work better for you.
Why black rough is more powerful?
I agree with the general sentiment of this message, but rough, for example, cannot format your code. So black and rough are two different things, but rough is indeed a really great static analysis tool, so I might be switching to this in my new projects.
Is the second talk useful for someone who's used GitHub Actions?
Partially. I will still be talking about the GitLab CI, but things that I will talk about can be transferred to GitHub Actions as well. So if you take the concepts from my second talk, you can probably take something out of it, even if you're using a different tool.
Okay, and the last question. My friend built and deployed by manually typing commands. How to make him change his mind?
I think it's going to be easier to change friends. I'm sorry.
So that was the last question. Thank you, Sebastian, for your talk.